Welcome to homework.
We are given strings, and we are asked to determine whether they are generated by the grammar given for postfix notation, and if they are, to find the steps used to generate this string. So in part A, we're given the string ABC star plus. Now, we see that the substring of this string, BC star, is a term because it consists of the factor B followed by the factor C followed by the mole operator star, short for multiply operator. So the entire expression consists of two terms. So we have A and then BC star followed by plus, which is an add operator. And so in steps we have expression. From this we can derive term add operator, and from term we can easily derive factor from our first term, from the second term we can derive factor mole operator, and from add operator we can derive a plus Now from factor we can derive identifier, from the other two factors we can also derive identifiers, from mole operator we can derive the asterisk, and finally we see that from the first identifier we can derive A, from the second we can derive B, and from the third we can derive C. And so we see that we obtain ABC star plus, which is what we had. And therefore it follows that the string is generated by the grammar given for postfix notation. In part B, we're given the string xy plus plus, see that the string is not going to be generated by the grammar. This is because the second plus sign needs two terms preceding it. And this is by the first syntax expression. However, we see that xy plus can only be deconstructed to be one term. And for that, you have to use the first syntax rule. So it follows that this is not generated by the grammar. Now in part C, we're given the string xy minus z star. So this string is going to be generated by the grammar. Notice that xy minus is a factor. Since it's an expression, in fact, the expression is the term x followed by the term y followed by an add operator. And the rest of the string is z star. And so the entire expression consists of two factors, where z is the other factor, followed by a mole operator, which is star. And so the derivation is expression followed by term add operator in the next step. The term can be replaced by factor. Oh, you know what? Hold on a second. So instead of starting out with two terms in an add, start out with one term. So expression, and then the next step is just term. But then from term, we get factor mole operator. From the first factor, we get expression. From the second factor, we get identifier. And from mole operator, we get star. Now, from expression, we get term add operator. From identifier, we get z followed by a star. And then from factor, we get identifier. From term, we get factor. From the other term, we also get factor. From add operator, we get minus and then z star. From factor, we get identifier. From the second factor, we also get identifier, then minus z star. And from the identifier, we get x, and from the second identifier, we get a y. And so we obtain x, y, minus z star. And so we've shown that this string is going to be generated by this grammar. In part D, we're given the string wxyz minus star divide. This is similar to a previous part, so notice that expression has two factors followed by multiplication operator star, division. So the first factor in this case is just w, and the second factor is xyz minus star. And then the term xyz minus star can be broken down as in part C. And so for the full derivation, we start off with expression. Next turn, this becomes term. And then term turns into factor mole operator. And we see that the first factor is going to remain, well, it's going to change from a factor to an identifier. The second factor is going to change back to an expression. And the mole operator changes to the division sign. And we see that this factor changing to an identifier is going to change into w. The expression is going to change into a term again. We still have the division at the end. And then we have w followed by, the term is going to be replaced by factor mole operator. Which is then followed by the division. The next step we have w, and the first factor is going to be changed to an identifier. Second factor is once again going to be changed into expression, and the mole operator is going to be replaced by star, multiplication, followed by division. In the next step we have W, and this identifier is going to be replaced by X. The expression is going to be replaced by term, add operator, followed by star, slash, and our term, both terms are going to be replaced by factor. So we get Wx factor. The add operator is going to be replaced by a minus sign, followed by star, followed by a slash. And then the factors are both going to be replaced by identifiers, so we get Wx identifier, minus star slash. And finally, the identifier is going to be replaced first by a y and then by a z, so that we get Wx yz minus star slash. And so in this way we've shown that the grammar does generate this string. Finally, in part E, we're given the string ADE minus star. We see that this is also generated similar to the previous parts. So we start off with the expression. Next step, this becomes a term. In the next step, the term, I'm going to have to sort of write these in columns here, becomes factor followed by a factor, followed by a mole operator. We see that the first factor is going to change into identifier. Second factor changes back into an expression, and the mole operator becomes star. The identifier changes to an A. The expression changes into another, well, it changes into a term, followed by a term, followed by an add operator. We see that both terms are going to change into factors, so that we get a factor, The add operator will be replaced by a minus, then star, and both factors will be replaced by identifiers, so we get a identifier, minus star. The first identifier will be replaced by a D and the second by an E, so that we get a D E minus star. And this shows that our string is generated by this grammar.